Okay, so we have this problem here. That's our PDF, and we want to find the probability that x1 is less than 3/4 and x2 is bigger than a half. So for these problems, the first thing we have to do is we have to graph them. Okay, so this is x2, x1. So we're given that x1 is less than or equal to x2. So let's graph the function x2 is equal to x1. So we're gonna go ahead and do that. So it's gonna look something like that. Now x1 is less than or equal to x2. So that means that x2 is going to be bigger than x1. So really what this is telling us is we have to look at all the values that are above the line. So everything above here. So x1 needs to be less than 1/4. So if we say this is 1, that's 1. This is 1, comma 1. So 3/4 would be around here. So let's go ahead and graph that. Okay. And x2 is bigger than 1/2. So again, let's just graph that. So if that's 1, a half would be here. So again, remember, we're going to have to look at values that are above the line. x2 is equal to x1. Okay. Oh, and I forgot. So this is, everything is bounded by the constant function 1. So our area of interest is going to be right here. That's going to be our area of interest. Okay, based on all the conditions that we were given. Okay, but here is the tricky part. The bounds of integration change for x2 and x1. So for x2, they change as soon as we get to this point here, which is 1/2, comma 1/2. Right, because the lower bound for x2 is going to be 1/2, and the upper bound is going to be 1, right? In this section here. Okay, so we go from here to here, and for this section right here, the lower bound is going to be this line here. X2 is equal to x1, and the upper bound is going to be 1, so this one. Okay, so that's why we have to split it into two areas, because otherwise we run into a problem, right? So we're integrating from here to here, but then the bounds are just going to change as soon as we get to this point, right? And likewise, if we want to start with x1, yeah, sure, we can, the bounds are nice and easy, up until this point, right? Because now the bounds change, right? So we have to find two areas. Let's just call this one yellow and this one green. Okay. So, okay, let's focus on the green part first. How are we going to integrate that? Well, the easier way to do it is this way. So these are functions, right? These are constant functions. So that is going to be our inner integral, right? So we go from, so this is going to be dx2, right? So we'll go from 1/2, and the upper bound is going to be 1. And then dx1, our outer integral, we go from 0, and then we end right here. So this point here is a half. Okay, so it's going to look like that. And our function looks like this. Okay. And for the yellow part, So if we go this way, they're constant functions. So that's going to be our inner integral. Okay, so it's going to be, again, it's going to be dx2. And dx2 in the yellow area is bounded by the line x2 is equal to x1. Okay, and the upper bound would be the constant function 1. Okay, and then our outer integral, so that one goes from 1/2 to 3/4. Okay, and it's going to be the same function. So then at the end of the day, we'll just have to add those two. We have to add the green area with the yellow area, and that should give you the answer.